Good morning. I am Syed Noor Rasool, team leader of Team IDEOGEN. I am from mechanical departments, and so are my teammates Rahman and Ritesh. Deepshika and Kashif are from the computer science department, and Santosh is from electronics department. Our mentors Nuzhat ma'am and Afnan sir have accompanied us. We are from Aurora's Technological and Research Institute, Hyderabad. Our problem statement is to mitigate the conservation and harvesting of rainwater. Ours is a multidisciplinary project where we have integrated mechanical, electronic and software aspects to make a completely optimized solution for our problem statement. Rahman, Ritesh and I have helped set up the entire project, and we have also modeled various 3D printed parts. Deepshika, Kashif and Santosh are responsible for sensors and website monitoring. Over to Deepshika, who will explain the introduction.
Purification of rainwater for achieving sustainable development goals in India by using embedded systems. So the main components of our project are catchment on the rooftop, filter consists of a mesh and a charcoal, a storage tank 1, and the purification tank consists of a potash alum, then another storage tank 2, which is for usage. And in addition to it, we are using the components like Node MCU, then Arduino UNO, and motors, DC motors, and sensors like rainwater sensor, ultrasonic sensor, turbidity sensor, and pH sensor. And our teammate Kashif will give a brief explanation about sensors.
Sensors which are in the workflow are rainwater sensor, turbidity sensor, ultrasonic sensor, pH sensor, and UNO. We have a Node MCU. So first of all, we will go through rainwater sensor. What is a rainwater sensor? So rainwater sensor consists of two boards. One is known as a raindrop module, and one is the controller module. Raindrop module has the copper threads. Raindrop modules have copper threads, and it is designed in such a way that when there is no rain, the resistance is very high, and when there is rain, the resistance is low. So raindrop sensor calculates whether there is rainfall or not, and the controller has a pin configuration of 4, and 2 pins are connected to rain module and 2 pins are connected to Arduino.
Okay.
These 2 pins are connected to raindrop, and these 2 pins are connected to Arduino for transmission of the data to cloud, for giving the signals. So the next is ultrasonic sensor. Ultrasonic sensor is connected over here. It is used for measuring the capacity or the distance, and it also has a module. Its module is over here. This one. It is the module of ultrasonic sensor.
This one.
Yeah, it has a pin configuration of 4, and the pins are connected to Node MCU, Arduino. This one. It is connected to Arduino.
This one is connected to this one.
This one is connected to Arduino.
And this one is connected to this one, and this is connected to all this in the center. Okay, continue.
Then the next sensor we have is a turbidity sensor. It is used to measure the quality of the water, and it checks the haziness of water, whether there is a fluid, and also it also have a component controller module. So its controller module is over here. Okay. It is a controller module of turbidity sensor. Its pin configuration is 8, but we are using 6 pins. Its pin configuration is 8, but we are using 6 pins. 3 are connected to the sensor and 3 are connected to Node MCU. Node MCU will give the output, the quality of the water. It will send it to the data server. Next we have pH sensor. pH sensor is used for it will check whether the water is acidic or basic. It is also having a controller. It is connected to Node MCU again. So next our ma'am will explain the workflow.
A very good morning to one and all. So my name is Nuzhat Farana. So here I am going to explain our project workflow. So basically we are using a catchment, so which is present on the top of the roof. So actually how this works? So this works it completely based on the raindrop sensor. So whenever we pour some water or whenever there is a rain, so this rain drop module, okay, it will detect the rain, and with the help of controller, so it will decide whether the resistance is high or low. So generally it is inversely proportional to each other. If there is a rain, then the resistance will decreases. If there is no rain, then the resistance will be high. So now what we are going to do is we are using L298 motor, driver motor. So with the help of this, it will rotate and the cover of this catchment will open up. So after that, whenever there is a rain, then the water will be passed into the filtration tank. So basically a filtration tank, it consists of a mesh and activated charcoal. So the activated charcoal, it works on the principle of adsorption. So adsorption means whenever there are any impurities present on the rainwater, so this activated charcoal, it will get absorbed. So basically we have absorption and adsorption. Adsorption, it is used to get the impurities. So whenever we have any impurities, then after that we are going to pass the water, okay, so which is a partially purified, not fully purified. So if you want to get a purified water, then we have to pass the water into the tank. Storage tank here we are using. So we are using two types of tanks here. So in the storage tanks, so basically we are using an ultrasonic sensor. So this ultrasonic sensor, it is used to measure the capacity of the tank. So how much the capacity we are using. Okay, so next we are using generally the capacity of the tank. It is we have programmed in such a way that it is greater than 7.5 liters. If we have filled the tank which is above 7.5 liters, then it will start pumping the water from one tank to the another tank. So here we are using a DC pump. So with the help of this motor, so if the capacity of the tank is greater than 7.5, then it will pump the water from this tank to the potash alum tank. So now we have a partially filled water. So what we have to do is we have to purify it with the help of a potash alum. So we are going to dissolve the potash alum here. So generally we are going to use filter 5 liters of water from this tank to this tank. Okay, so we are using generally 4 grams to 5 grams of potash alum, so which is dissolved nearly, it will take 1 hour of time. So after that, so we'll get to know the clarity of the water or the clearness of the water with the help of a turbidity sensor. So we are using a turbidity sensor, so which is used to check the clarity of the water or the clearness of the water. Next, if you want to check whether we can drink the water or not, so which means we are using it with the help of a pH sensor. So basically a pH sensor, it is used to specify whether the water is acidic in nature or basic in nature. If the water is generally it is basic or it is drinkable, then we can store it in with the help of a separate tank. So next, the programming part will be discussed by Santosh.
Water will be pumped to this tank. And also there is another condition in this tank. This tank should be empty to send water from this tank to this tank. Both conditions should be satisfied. So that this is a time-consuming process, like 1 or 2 hours. So we'll store the water here until the pH value gets between 6.5 to 7. Yes, sir. Right. So as you can see, the water level of this tank is 2 liters. And the water level of potash alum tank is 0. This is in liters, represented in liters. And we have pH, there are no water. When there are no water, we'll get a pH of 5.3 to 5.4 when there is no water. After this, we are updating all this data to server. So if there is no water, even this data will be uploaded to server. Storage tank mein 2 liters. And potash alum tank 0, turbidity is clear.
Data will be refreshing for
every 15 seconds. Every 15 seconds.
It's 11:23.
11:23. Okay. Now let's pour some water into this so that the water starts flowing from this to this. This is also a little bit time consuming.
Reading is moving.
Yes, sir. It will move. The water is a little bit slow here, so it will move a little bit. 3 liters. It's 3 liters now.
check the readings.
We'll also update over there. You can see that 2 to 3 liters updated, and here too we can see that 3 liters
Updated data.
updated data.
This is your website.
Yes, this is for a development purpose to show you.
So we are migrating the data from the controller to website.
That turbidity is showing that
It is clear. Yes.
What do you mean by clear?
It means the value. I mean, we'll get a digital output from here, sir. The NTU will be below 110. So whenever the NTU is below 110, it will show clear. The sensitivity of this.
What is range of clear?
I mean that the dust particle. There are no dust particles in the water.
I know that is turbidity, but I am showing the value of turbidity. I am asking
Clear.
about the
It is
turbidity
below
value.
110 NTU. Below 110 NTU.
We can drink,
Yes, sir.
but WHO is saying that 5 NTU we cannot drink.
Yes, sir. But the sensitivity of the sensor is little bit higher. That is why we gave it to 110.
It is just
Is for a prototype. As if you want to use turbidity sensor more efficiently, then
you
we,
can run, you can
yes,
you can decide.
7 liters or
So the readings are
7.
6 to 7 liters. And this water is tank is
The motor turns on.
motor start.
The motor is shut. The water will pump from this to that tank. Pipe. Yes. Is the water flowing? Flowing.
The second tank, it is getting filled.
फिल्टर नहीं हो रहा, अभी नहीं हो रहा। देखिए the water flowed into the tanker 5 liters. After 5 liters, the motor will automatically turn off, and we can see the pH rising over there. Rising or based on the pH value.
Reading is
Yes, sir.
5.77.
Yes, it will take 1 minute to yes, sir. To give accurate
Now we
values,
are
it will
going
take.
to add the potash ion in the potash ion tank.
You already
And
we have to put
we have
What is purpose of including potassium?
potash ion. It is used to dissolve with the help of potash ion. So suppose we can decrease the
Value of
water.
here it will be the pH will be
For sedimentation.
Sorry, sir.
It is for sedimentation. Usually potassium is used for the filtration of water. When we have more turbidity, then we have to add potassium. Potassium is just curing
it will kill.
It is cooling agent.
I lot
tell me, sir, about the protection.
Water is transmission here through activated samples. Here water is purified up to 60%. Generally rainwater it has calcium ions, magnesium ions and few salts. So it will remove it up to 60%. Then will pH it will make the pH to around 7.
it will increase the pH.
Between 6 to 8. But still for removing hardness, because it cannot remove hardness. Potassium removes hardness and the leftover bacteria. That's why we are using potassium by second filtration we are using.
Main motor is using potassium is removing hardness.
No.
But this type of hardness, temporary and this type of
Temporary rainwater and temporary hardness. Because calcium
rainwater is also having sulfate and magnesium sulfate. It is causes of permanent hardness. Temporary hardness we can remove by boiling. That is the only method by which we can remove temporary hardness. But for removing permanent hardness, we have to use DDTA, photoreplacement. Potassium is main motto of potassium for sedimentation. If we have some impurity in water, then potassium can get settled down there. Potassium cannot remove the hardness.
Sir, can we use dash along on a daily basis?
Yes, sir, we can. Also, we do we have in our underwater tank, then we have to add water saline, Big 3, that is H2SO4 L2SO4, that is formula.
AL2SO4.
How it will make
Rainwater does not have very large amount of salt. The amount of salt which it has,
if rainwater don't have that large amount of salt, then we can use it boiling, by which we can remove the
for boiling unit, we need to have a mechanism for heating that will increase the cost of the moving power. So to make the less cost, we are using this.
So we need potash mix curry for rainwater. Actually, we need that mix curry for the rainwater.
for sedimentation, for settle down in the impurity. Get water saline cannot remove hardness.
Impurity is like dust.
Heavy particles. But water saline is a fluctuant agent, coagulation. We can remove only dust or impurity. If
What is the pH? Last first time same thing.
You is from civil?
No.
Potassium and art can
Now the pH is 5.8, sir.
Is it drinkable or not?
As of now, it is not, sir.
What is range according to BIS of pH?
It's above 6.5 and below 8.5, I guess. I'm from electronics. Sir?
Yeah, sure. Actually, we have tested it for so many times.
I'm sorry, all the
sensitivity.
sure, sir.
It is not wastewater, it is rainwater. It is less impure and it is also semi-partially recoverable. We have done iterations to experiment, and we came up to like 1 gram per liter.
Okay, sir.
10 gram for
10 liters.
It's 10 liters in it.
5 liters.
5 liters.
Use 5
Yes, sir.
Use 5 grams. 5 grams.